So as we take a look here to start the last video of this section, you'll see another statement from the Common Core standards for math. This is grade 2. Notice that first word, mentally. Mentally add 10 or 100 to a given number, 100 through 900, and mentally subtract 10 or 100 from a given number, 100 through 900. So this much of this video is going to involve mental calculations, specifically with addition and subtraction. And that's one of these skills that some people have really honed and developed over time, and other people sometimes struggle with that. And I think when they do struggle with it, they have a belief that they're simply unable to do it. That it's something that their brain just isn't capable of doing, or they might say, "I'm just not a math person. I can't do that." But a lot of times it's because they have not been introduced to different strategies. They think that the way that you do math in your head is the same way you would do it on paper, and it's absolutely not, at least in my experience. But mental calculations are important. They often prove the quickest, sometimes the most convenient method of obtaining an answer, but it does require the use of a number of skills and combining them into one process. We have to be able to use various algorithms. We have to understand place value, base 10 numeration, and also we have to be able to use some number property. And they are incredibly useful when we're trying to obtain exact answers, which is sometimes necessary. But as we're going to see later in this video, when we talk about approximating and estimating, mental calculations are a prerequisite to approximating answers. So we're going to look at 3 or 4 different techniques for performing mental calculations, and then we'll go on and talk about how we can use those to estimate and approximate. So the first technique we're going to look at here is called using compatible numbers for mental calculation. And this is really just looking for nice, convenient numbers, pairs of numbers whose sum or difference is easy to compute. For example, let's just say we have to add, to start, 17 plus 43. In your head, go ahead and do that in your head. Pause, do that calculation. And what you might notice when you try to do that in your head is that I gave you numbers that had what I would call compatible numbers in the ones digit, in the ones place. 7 plus 3. 7 plus 3 makes a nice 10. So when we're adding the 17 and 43, those two make 10. The 1 and the 4, that's 10 and 40, so that makes 50. And what we end up with here is 50 plus another 10, which is 60. So the 7 and the 3 link together nicely to make a 10. Now what we'll do is we'll extend this to a more complex problem. 17 minus 12 plus 43. We need to do this calculation. So when you look at a problem that has 3 numbers, 2 operations that you have to do, you can rearrange it. We're starting with 17, we're subtracting 12, we're adding 43. But these 3 things, I'm going to block in the 17, I'm going to block in the minus 12, and I'm going to block in the plus 43. We can really move these things wherever we want because of the commutative property of addition, which we talked about before. So long as we make sure that the minus stays right in front of that 12 and that the plus stays in front of that 43, okay? So what I'm going to do is I'm going to switch these two. And I'm going to make this 17 plus 43, not like that. 17 plus 43 minus 12. Why did I do that? So I can see these two numbers together right next to each other and then associate them together and add them together first. We already know that those make 60, and then we can do 60 minus 12. 60 minus 12 is equal to 48. Now, the way I do that in my head is I take 60 minus 10 and then minus another 2. We're going to talk about that in our next, the next section. But you can even subtract 12 in 2 steps. First, take away the 10, then take away the 2. And so we end up with 48. So you can see how even in this problem, we try to match up numbers that were nice. So this is a great opportunity for you to do practice on your own of these strategies as we go. So let's go ahead and try these 2 problems on your own. Here are a couple good examples for you to try on your own. Pause the video and see what you can come up with. So on this first one, what you might notice is that we've got a couple numbers that match up nicely. The 17 and the 23. Again, it's the 7 and the 3 that add up to a 10. So it's going to give us a nice 0 in that tens place. So I'm going to rearrange these to be 17 plus 23 plus 12 plus 45. And then I'm going to group the 17 and the 23 together, associate them. Why? Because again, the 3 and the 7 make a nice 0. We end up with 40. And then these two, those don't necessarily have nice, neat numbers, but we can still add 12 and 45 to get 57. I like to start with the bigger number there. 45 plus 10 is 55, plus another 2 is 57. So that's how we can do some of that stuff fairly quickly in our heads. Now, because we worked with that first pair well and we have a 0, all we have to do is add the 40 to the 50. Add the numbers in the tens place to get 90, and then we have 97 as our solution. So I'm wondering, is that the same thing that you did mentally? Let's take a look at the next problem. Here, what I notice is we have 5s, 15 and 55. Those usually work nicely together. And then I noticed that we have some 2s. So we're going to see what happens there. So I'm going to start by flip-flopping these and say 15 plus 55 plus 82 minus 12. I'm going to group the ones that end in 5s together. 15 plus 55 is 70. Again, 5 and 5 is 10, plus 50 plus 10 is 70. And then these 2, I'm also going to group together. The positive 82 minus the 12. Again, because the 2s are the same, we can take them both away, subtract the 0, and then it's just 80 minus 10, which is 70 again. 70 plus 70, add the tens columns to be 14, and so that's really going to be 140. And so again, this is finding compatible numbers. Compatible numbers usually are going to add up to be some multiple of 10 or 100, something that ends with some 0. So always look for those. So your next strategy is what we will call substitutions for mental calculation. I showed you something like this earlier, maybe in another video. And so with substitutions, a number is broken down into a convenient sum or difference of numbers. Again, I use this one all the time. Let me show you what this could look like. So imagine the problem 127 plus 38. Say you have to do that mentally. There are several different ways you could do it. Pause and see if you can do it on your own first, and then come back. So this kind of combines the previous method as well, looking for nice numbers. Again, there's not just one way to do it. Here's what I would do. If it were me, here's what I saw. I notice I'm starting with 127. Because this ends in 7, a 3 would be really nice to work with. So what I noticed is that I could take the number 38 and break it apart into 3 plus 35. It's still equal to 38. There's still 38 things there. And then it even kind of starts with parentheses around, but then what we really do is we end up shifting the parentheses, oops, so that the 7 and the 3 pair up nicely together. Why? Because 127 plus 3 is 130, and then adding 35 is fairly straightforward. Adding the 30s makes 60, so we have 165. Can you see any other ways you might make some nice numbers? Another way you could do this same problem is to take your 127 and then your 38. Maybe you break 38 up into 30 plus 8. Why would that be helpful? It's always easier to add a number that ends in 0 because we just have to add the 2 and the 3. They're in the tens place. So these two would make 157. And then to add 8 more. You could even do it again and think about 8 as 3 plus 5. 157 plus 3 is 160, plus 5 is 165. So you can do it multiple times, even in the same situation. You don't have to just change the 38. 127 plus 38, you could take 127 and make it 125 plus 2. Why would we do that? Because 2 pairs nicely with the 38. And we have 125 plus 40. Again, add the tens numbers, and you get a 6, 165. So you can see there are multiple ways to do this. There's no just one right way. Go ahead and try these using this method. Use the substitution method. So let's do, let's try 57 plus 24. Go ahead and try that on your own. So again, there are lots of different ways you could do it, but the way I saw it was 57 plus. I immediately said, how do I get my 57 just up to that next multiple of 10? That would take 3. And then if I remove 3 from the 24, I'm left with 21. Right? So this is still equal to 24. I grouped the 57 and the 3 to get 60. And then I had 21 to get 81. Maybe you did it that way. Maybe you took your own strategy. Either way is fine. Now, this next method, I don't use this one as much as the previous two examples, but it is a nice, it provides you another option. This is called equal differences for mental calculation. So equal differences. And this one really uses the fact that the difference between two numbers is unchanged when both numbers are increased or decreased by the same amount. And sometimes you can replace a difference by a more convenient difference. Let me show you what that might look like. And I'm gonna use some visuals for this. So this is, let's do 11 minus 7, okay? Use some simple numbers to start with. 11 minus 7, and you probably just know that the difference of that is 4. But one way you could do this is say, all right, what if I just took 1 away from both of those numbers, right? Change them both by an equal difference and said it was 10 minus 6. 10 minus 6 for most people is going to be an easier calculation. Starting at that 10 usually is nice, right? 10 minus 6 is 4. It's the same difference either way, but this one might be easier for some people to do. You could also add instead of 11 minus 7, you could say, maybe I always want to go up to the next multiple of 10. So that would be adding 9 to both numbers. 20 minus 16. It's still 4. Here's what that last one would look like if we looked at it as a picture. The original subtraction problem that we're trying to find is this. 11 minus 7, what does that leave us with here? But if we add 9 to both of them, that's where this 20 minus 16 comes from. And again, that might just be an easier calculation for some people to work with. So you can adjust, right? That's what it's all about. It's okay to adjust both numbers. So why don't you try this one on your own as well with the example of 47 minus 18. See if you can use the method of equal differences. So whatever method you used, and I maybe even try different ones, see if there are different ways you can do it. Find the one that you like the best. You should end up with the solution of 29. And here are several ways that maybe you thought about it. So again, we had 47 minus 18. One way you could do it is add 2 to both numbers. If you add 2, you end up with 49 minus 20, which is 29. Maybe you added 3 to both numbers, because that made the first number a nice multiple of 10. 50 minus 21, also 29. Maybe you subtracted 17 from both numbers. Minus 17 to get 30, minus 17 to get 1. 30 minus 1 is 29. Or maybe you subtracted 7 from both numbers. Changes that first number to 40, the second to 11. 40 minus 11 is 29. So as long as you're changing both numbers equally, the difference remains the same. The key is to try all sorts of different options so you can find the one that works best for you. And you'll hear that as a common theme, okay? Find the one that works best for you. But in order to find that, you've really got to try all of them. Let's look at one more. So this is called the add up method for mental calculation. And I've talked about this. This is often the way that I do my subtraction. At least for me, this is one of my favorites. And so if we have to do 54 minus 19, okay? 54 minus 19. The way that I picture that in my head is I kind of picture something like this. This just sort of appears in my head. If I'm starting at 54 and I'm taking away 19, again, I'm finding that, we called it, remember the missing addend? How much do we have to add to 19 to get up to 54? And I do it incrementally. The first thing I'll do is say, all right, 19 to get up to 54. I'm going to add 1 to get up to 20. And then from 20 up to 54, I've got to add 34, right? So I go to the first nice, neat number possible that I can find, and I know that's 1, and then I add another 34, and so I know that that adds up to 35. So that has to be the difference between the two numbers. There are, again, different ways you can do this. I think in a previous video, I gave you the problem 87 plus 15. 87 plus 15. And I kind of even do that the same way with the add up strategy, where I'm looking at 87 and I say, how much do I have to get up to be a nice number? And I like the number 100, and 13 gets me up to 100, and that leaves me 2 more, right? So again, I'm always picturing going up or down to that next closest multiple of 10. Why don't you try one? Let's do this. So we're going to do 57. We're going to subtract. So this is going to be subtraction. 53 minus 17. And then we'll do a second one as well. 135 minus 86. We're going to use the add up method where you start with the lower number to see how much it takes to get up to the bigger number. So you can do it in more than one step as well. So for this first one, let's see what you did. 53 minus 17. The first thing you might do is add 3, because that gets you up to 20. And use any notation you want to do here. Then I have to get from 20 up to 53. Maybe you go incrementally. Maybe say, okay, I just need to get up to 50. So that would be adding another 30. That gets me up to 50. And then I have to go 3 more to get up to 53. There's my 53, 3, 33, 36. 36 would be our difference. Okay, that's, again, one way you could do it, and there are many. For 135 minus 86, how did you do that? For me, the first thing I thought of was, well, I'm going to add 4 to get up to 90, and then I'm going to add 10 to get me to 100, right? Once I get to 100, now it's pretty easy to get to 135 by adding another 35. So 14 plus another 35 gets me to 49. Okay, so I'm adding up plus 4 plus 10 plus 35. It's not the only way to do it, but hopefully you're seeing now some of these different ways to think about subtraction that you might not have thought of or even possible before. And that leads us to our final topic, which is estimation and approximation. And a lot of the times these words get used interchangeably, but they are different. And so I'm going to paste our definitions that we're going to use here. So we use the word approximation when we're referring to a technique in which we simplify a calculation by doing something to the numbers involved, such as rounding. Okay, so it's really simplifying the calculation. We use the word estimation to mean the making of an educated guess as to a quantity or measurement. Okay, so those are somewhat different as far as what they do and their purposes. Okay, they both lead us to answers that aren't exact, and that's okay. There are many times when we don't need a precise answer. We just want to get close. So the first thing we're going to talk about is approximation by rounding. Okay, approximation by rounding. Sometimes, again, all you need is an approximate sum or difference. And the way you can do it, a lot of people like to round once they get done with the calculation. But in this case, we could round the numbers before we compute. So we round before computing. And we're often going to use this symbol. This little wavy equal sign means is approximately equal to. Okay, is approximately equal to. Now, where do we round to? It really depends on the problem that you're working with. Sometimes it's up to you to be the judge. Sometimes you're going to be instructed where you're going to do your rounding to. What we're going to do is we're just going to round each number to the leading digit. Okay, so for these, we're going to round to the leading digit. So imagine you have to subtract or do this problem. 624 minus 289 minus 132. That could be a bit complicated for you to do in your head. And maybe all we need to know is, can we get close? Can we approximate? So if we round them all to the leading digit, we'd be rounding to here, and to here. And if you recall from a previous video, we always look at the next digit. Because 2 is less than 5, we will round this to 600. Because 8 is 5 or greater, we will round this up to 300. And because this digit is 3, it's less than 5, we'll round down to 100. Notice what we have. Fairly easy numbers to work with. 600 minus 300 is 300, minus 100 is equal to 200. And we're going to use that approximately equal to sign there. So we can say that this is approximately 200. Okay, it's an approximation. You go ahead and try this on your own with these two examples. 4,723 plus 419 plus 1,040. And for the next one, we will do 812 minus 245. And remember, round each of them to their leading digit. So for number 2, we have leading digits in the thousands place, in the hundreds place, and the thousands place. And so our rounding will be 5,000, because that 7 is 5 or bigger, plus 400, that 1 says we round down to 400, plus 1,000, because we have a 0 here. 5,000 plus 400 plus 1,000. I'm actually going to add these two first to get 6,000, then add the 400. That was my approach. So we can say that this is approximately equal to 6,400. For the last one, we have 812 minus 245. And so we'll round that to 800 minus 200, which is 600. So we can say that this was approximately 600. Okay, we are approximating our solutions there. Now, another approach to approximation can be incorporating one of the strategies we actually talked about earlier in this video, and that is finding compatible numbers. So rather than just rounding to the leading place value, we can round in a way that gives us nice numbers, nice compatible numbers. 342 plus 250. Let's say we have to approximate the solution there. Well, I've got a 5 in that tens place. This is pretty close to 5 there in that tens place, and those are very compatible numbers because they add up to 10. So I'm going to round this first number to 350, and I'm going to leave 250 unchanged. 35 plus 25 is 60. So this is going to be approximately 600. Again, the 300 plus the 200 is 500. The 50 plus the 50 is another 100. That's where we're getting that 600 from. So we don't have to round the whole to both numbers. We can just round one of them if it's convenient to us. So it's another nice approximation technique. Go ahead and try a couple of those on your own. So this was number 1. Number 2, let's do 142 minus 119. And then for number 3, we will do 127 plus 416 minus 288. So go ahead and pause and try those on your own using compatible numbers. So what I saw here for this one is that I'm just going to round them both to the nearest 10. I'm going to round them both to the nearest 10. 140 minus 120. For me, that seemed like the easiest thing to do. And 140 minus 120, I'm using the counting up method. 20 plus 20 gets me to 140. So I know that that is going to be my difference. So that has an approximation of 20. For number 3, what I might do is looking at these, and I'm thinking, again, rounding to some tens places might be helpful. But as I look at it a little bit more, I think I'm going to round this to the nearest 10, 130. This is actually fairly close to 400. So I'm just going to round this one down to 400 and this one up to 300. Okay, because those were hundreds there, and they were fairly close to the nearest 100. So I'm just going to go to the hundreds. 130 plus 400 minus 300. When I calculate this, I might even do this first and say 400 minus 300 is 100. And then 130 plus 100 is 230. again, you didn't have to do it like that. That was just how I saw it. And again, you can make some of your own judgments when it comes to approximations. All right. So the next one that we will look at is called front end approximation. Front end approximation. And this is really kind of what we did a minute ago, where we rounded the numbers to the first digit, except we don't even round. We actually only, when you're doing front-end approximation, you only use the first digits. You don't even bother rounding. So let's say, and sometimes this can be helpful, like if you're doing a monetary calculation, and again, you just need to get something quick. Here's a scenario. You've written checks for $433, $684, and $228, and you wish to quickly approximate the total. That's the key. It's quickly. If you're going to do front end, all you do is you look at the first digits. You say these are all counting by hundreds. They're all in the hundreds. And so if we're adding 400 plus 600 plus 200, so you got the 4, the 6, and the 2, that adds up to 12, and we're counting hundreds. So that gives us a really quick estimation of 1,200. Now, it's certainly less than what the actual amount would be, but again, it's all about quickly getting an approximation. So when you do front-end approximation, again, you're not even rounding. You're just focusing on what are the first digits. What are the first digits? So let's do a couple of those. Give you a chance to practice that. That might be a new one for you. Let's look at, if I can get my pen to work. Let's look at 1,306 plus 7,247 plus 3,418. And let's also look at 7,316 minus 547. So use front-end approximation for these. Go ahead and pause and then come back. So for number one, what you would do if you're using front-end is 1,000 plus 7,000 plus 3,000. You're just you're leaving zeros after that first number. I look at the 7 and the 3,000. That makes a nice 10,000 plus 1 is 11,000. Okay, so we're just focusing on those front end numbers. For number two, we have this would be 7,000 minus 500. This is going to be 6,500. Okay, so in that case, we had different place values where we were rounding to, but still, we're able to quickly do that calculation. And so hopefully from this video, you have learned maybe some techniques, you've been introduced to at least some techniques of subtraction that you can do mentally, and some approximation techniques, ways that you might not have thought about before. These definitely take practice as you go along. We're going to challenge you to try these new things out so that you can get comfortable really with all of them and look for the best situations in which to use them.